Our fun with that thing called discrete and continuous functions. So if you're in your Google slide, you could click on the click here for the activity. You could get there from our classroom assignments in Google Classroom, or you can follow that link I put in the chat. All kinds of ways to get here. But just a heads up, this is the first slide you're going to see. It's not actually asking you to enter information. It's trying to give you information, but that has been quite confusing along the way today. Julia. Malcolm is perfecting the best way he can respond that you will feel supported. That's the only reason he hasn't responded yet. So just give him time. Malcolm, stop it. We know that you're asking what happened to the dog water. And my dog's water is still over on the other side of the steps behind me. So thank you for asking. Be nice to one another. Anyway, so you can click right past this silly looking slide. It's not really that you need a class code. It's just that you got to get past that silly looking slide. Okay, let's see how we're doing over here. Oh, Malcolm missed out. I see. All right, we already got 6 of us in, but we need a whole 14 of us in. So we're missing 8 peoples. Everybody join in because we're actually going to work through the first. We're going to work through the first 10 slides together, you crazy peoples.
So we're going to the slides and then we're going to go to the link on there.
So I'm trying to decide, Malcolm, is it that you lie in dog water? I can't figure this out.
I don't lie in
Anyway,
water.
What was your important question there, Sir Malcolm?
So where did we go for that? To the Google Slides?
You could, or Mr. Blake just put it back in the chat. That link right there, if you just click on it, is going to take you to this weird slide. But this weird slide is just an information slide, not something you need a class code for.
Very rude.
Oh, no, it is a weird slide. So just click right on to the next one, and then you don't have to stare at that weird one.
It's so hot in my room.
Because somebody's got the heat on, which is better than being below freezing in your room, even though hot's not fun.
I want it to be below freezing. It's super uncomfortable when it's hot.
Well, I don't know how close your room is to the bathroom, but if it's very close to the bathroom, you don't want it below freezing or your pipes are going to freeze. All right, Anas, we can work with that. It is what it is. Sometimes that's a true statement, unfortunately. It is what it is, and we'll just deal with it somehow. Jalea, thanks. I almost said that, but I thought, well, he may not have a window.
Okay.
They've got him in one of those interior rooms, so he can't, have people coming in through his window and stuff.
Why they call me Jennifer?
I'm telling you, that's not calling you Jennifer. Everybody sees that slide. It's the first weird slide. I don't know why the person that made this put that on there other than to confuse us. So just
he
click.
Didn't even answer my question. He's rude.
Just
click. I don't like him now. I feel disrespected.
I'm not sure what your question was. Can you tell him?
I asked Malcolm, did he want to be friends?
Oh, awesome.
How do you expect me to hear that? Man, you know what? I'll be today, yeah.
Ah, awesome. Thank you guys for being friends. You can be our model friends for class today.
I'm about to leave.
Forget that. It took him 5 minutes to answer one question.
Because I didn't hear you. You talk too low.
Okay, I didn't even talk. I put it in the chat.
Yeah, it's just that we have too many people entering stuff in the chat, so it goes right on up the screen and we miss it.
If your computer wasn't made of dog water, then I would have seen it. Oh, now I see it. I had to scroll back up because too many people was typing.
All right. Moving right along. Thanks so much, guys. So we now have 9 of us in there. I'm still waiting on the remaining 6 of us to get in. I'm so confused because Malcolm seems to be talking to Malcolm and Jalea seems to be talking to Jalea. It's a very interesting conversation going on here.
What did I do? What did I do? What did I do? Okay. See, they always trying to turn me into the bad person. You see,
All
nobody's on my side, and I could care less.
I'm on your side, and so are you. But let's see if we can put this aside for now.
Yes, sir.
Be on everybody's side. That's the goal. As we are a team, if we can all be on the same side.
Team loner.
For example, yesterday, Mr. Reed totally got something he was supposed to do. No, that was Wednesday, for a whole group of teachers. And I called somebody and let them know. I'm like, I'm so sorry. And I apologized to the whole group. And the whole group's like, no problem. That's why we're all here together, to work together, to take care of each other. That's what we got to be. Figuring out how to practice that team concept. It's a good thing. And there isn't anybody in this class or anywhere else that is a bad person. Might make bad choices on occasion, but not a bad person.
I was going to name myself Malcolm the Dog Water, but I just put my last
name. Do it. All right. Here we go. We're still missing quite a few people, guys. I'm not sure why that is. You're going to definitely miss out if you can't hop in this activity with us now because I'm going to walk through these first several questions with you, and you'll be able to ensure you have correct answers as we get started here. It's going to be hard to do after the fact, but your choice. So don't get mad at me. I'm about to bring everybody together on the same slides for a short while to do these first 10 slides together. And then I'll stop trying to take control of your hard work and you guys will be able to go at your own pace. So if you're not on slide 2, you're about to suddenly be sent there so that we can work together. All right. So slide 2 is where I need to enter my name for this activity. Then it'll just kind of personalize the activity for me a little bit. And if I press enter, it says, thanks, Mr. Reed, for working hard today. We are excited to help you learn. You can do this.
You can.
We can all do this together. All right, so I'm going to skip 3. It's kind of informational, but you'll get all the information as we start working through this together. So on number 4 here, it says decide whether the following representations are functions or not functions. So they give us a little box that says function. They give us a little box that says not function. And remember, when we're looking at sets of ordered pairs, the way we know if it's a function or not is if every x value is assigned only one y value. So if I start out with this one that's got a bunch of zeros as the first numbers, this 0 here, its x value of 0 is assigned a y value of 2. That's fine. Here, the x value of 0 is assigned a different y value. That's where we have a problem. Every value in the domain, the x's, has to be assigned only one value in the range, and 0 is clearly assigned lots of different ones, so it's not a function. Okay. And I look at this one. I'm looking at all the first numbers because if each first number only appears once, then I can automatically say, yes, it's a function. Here we have a 3 and then a -3, a 5, but there the 3 repeats itself. So the next question is, does it show up with the same range value assigned to it? Here, 4 was assigned to the 3. Here, 4 is still assigned to 3. So it's a function because even though 3 showed up a second time, it still has only one value assigned to it. Come on. Oh, and one thing I didn't point out is you do have to make sure that when you're putting these cards together, you hover over it until it shows up with a blue outline like that. That's telling you the cards are connected, because when Desmos checks your answers, that's the only way it's going to know whether you have it right or not, if you actually have these cards connected together. So here's another one with a bunch of zeros, but all these zeros are second number zeros. They're in the range. The question is, first number 2, first number is 3, first number is 4, and first number is 5. None of them appear a second time. So yes, 2 is assigned exactly one value in the range, and 3 is assigned only one value in the range, and so on. So this one is a function. Here is one where we have 8 show up a second time, but it's assigned a range value of 4. Here, 8 is assigned a range value of 10, not a function. Have to always have exactly one value assigned. Okay, so here we got 4, 6, 1, and 5, definitely a function because none of those x values show up more than once. And 4, 5, 7, and 6, same thing. None of those x values show up more than once, so they definitely each just have one range value assigned. All right, so we had 2, uh-oh, Mr. Reed put those in the wrong places. These were definitely functions. Thanks for trying to clue Mr. Reed in. You know, you got to take care of him a lot of the time. So these are not functions, and these 4 are functions. All right. Earlier, these were on the opposite sides that they are now when I was doing it with another class. So, you know, Mr. Reed's brain stopped reading and just trying to assume. I've done a little too much of that today. That's not a good thing. All right. So I see that several of us already have that correct. And let me show you real quick how us teachers know that. That check mark right there, that means, yep, you got them all correct. If we go to the next card, it's going to tell me, whoops, I'm not on the student view though. Great work, you got them all right. So I did get them right. It would have told me I didn't have them right if I had left it the way it was. But back to what I was saying on this summary, those of you who didn't get them right have X's. We're going to want to go back and fix them because that's part of your grade for this fun-filled activity. All right. And you can go back and fix them after a while. Mr. Blake and myself can both help you out with that if you're not sure what in the world is keeping you from having a right answer. All right. These are graphs. Remember our vertical line test that says if you can find any vertical line that would hit the graph more than one time, then it is not a function. So based on that idea of a test, there is nowhere that I can draw a line straight up and down that would hit this more than one time. Okay, so that means that graph is a graph of a function. However, if I look at this graph right here where it's labeled 5, the reason the vertical line test works is because what I'm doing is looking at all the possible y values for the x value of 5 at the moment. And there's a y value for 5 down here that's near -2, and there's a different y value that's a little above +2. So there's a domain value that's assigned more than one range value, can't be a function. That's the reason the vertical line test works. This also is not a function. And this, there's no vertical line that's going to hit it more than once. It's a kooky looking graph, but sure enough, it's a function. This is a function. And this guy, just in this one little area right here, if I try and draw a vertical line, I would hit the graph there, then a second time, and a third time. So that clearly is not a function. Okay. Any questions out there?
No.
Anusha, that shouldn't be any problem, but after we're done here, you'll be able to go back if you want to go back and fix that.
Can you explain graphs more? Because I don't understand it.
I want to be a real smart aleck for some reason, Jalea, so I'm refraining. I don't know why I suddenly just really want to be a smart aleck. Let me see here. I'm going to see if I can draw on there and answer the question a little bit better. How come it's not working? Okay, I'm not going to draw with that at the moment. That's interesting. Don't know what's caused that, but I'll draw with this instead. Let's go back and, yeah, hold on. So if I go back and I try and draw on that, you know, the vertical lines are the ones that are going up and down. This vertical line is hitting the graph right here, and it's hitting it right here. The vertical line test says if you can find any vertical line that would hit the graph more than one time, then it is not a function. So that one, we have that problem right there. Let's see here, gotta clear that. Whereas if I look at any of the graphs that were over yonder, it wouldn't matter where I draw a vertical line on that one. All the vertical lines I can come up with, and I can't draw a vertical line with my mouse worth anything, but every vertical line is only hitting the graph one time. When I say the graph, I'm referring to whatever line or curve has been graphed. So you see one time, one time, one time, one time. Jalea, does that help a little bit or still confused?
I'm still kind of confused.
All right. Is there something specific that I'm saying that's not making sense?
Kind of. The only thing that's not making sense is like the vertical line test. Like, I don't know how to describe it.
Um, let's try this. I don't know if this will help. I know it would help me because I'm not good at hearing people say something and remembering it. But this is what the vertical line test says. If there is any vertical line that would hit, or if we use our math vocabulary, intersect the graph of a function more than one time. That right there is the big deal, more than one time. Yeah, well, let me do just part of it. Then it is not a function. Okay, so the big deal is if you can find any vertical line, you draw any vertical line anywhere on the graph, if you can find just one place that it's going to hit the graph more than once, then that is how we know it's not a function. If every vertical line you draw, no matter where you draw it, hits the graph only one time, or if it hits it none, that's all right. That's when we know it's a function. The other way that I put it when we were working on it was I said, if there is any part of the graph above or below another part of the graph, then it can't be a function. So here we got a part of this graph that is directly above this part of the graph. Not a function. Here we got a part that's directly above another part. In these, there's nothing directly above. Like if I look at this and try and go up or down, I'm not going to find any other part of the graph. There's not any overlap in terms of up and down. Alrighty. So if you could use some more help trying to think through that, I'll be glad to do that. Or maybe Mr. Blake, did you have any other way that you're looking at it or thinking about it that might help?
I'm not too sure, Mr. Reed. Usually I explain it how you do. I'd follow your lead. So
Okay.
maybe we could look at it in tutoring if you want to come to tutoring or next week.
Awesome. All right. We'll keep going for the moment. Thanks for hanging in there, guys, and being helpful. Moving right along. So let's see if Mr. Reed got this one right. Hey, I got it right. I hope it's telling you got it right. I see a few people that something's wrong. It could be as simple as you didn't manage to get all the cards connected, even though you lined them all up. So, all right. This is just filling in an XY table based on this function rule. 3 times the value of X is going to get us our Y's. So if I do this, of course, you could pull up Desmos, the graphing calculator, in a different window and do all of this. I'll just go ahead and do it though. -4 times 3 is -12. And then you see it graphed -4, comma, -12. Just be aware that it's going by ones on the X values, but it's going by 2, 4, 6, 8, 10, 12 by twos on the Y axis in this particular graph. So this is going to be -3. And then we have 0, 0, which of course is the origin where the axes cross. And then 2 times 3 is 6. And 3.5 times 3 is going to be 10.5. 7 times 3 will be 21. And 5 times 3 will be 15. I don't know why they're out of numerical order like that, but oh well. So right now we're looking at a graph of dots. And this would be an example. You're going to hear more from the guy that made this, but this would be an example of a discrete function. If this is all that's on your graph, you see that those are individual numbers, that individual values of X, these values right here, that are being graphed, and there's not anything connecting them. So it's discrete, not continuous. But
You put a O.
What's up, Malcolm?
You put a O instead of a 0 by the 10.
I would never. Thanks, my man.
Mm-hmm.
Yeah, what? It graphed it though. Let's see if that really is an O. No, I think it must be a 0. I see why you're saying it, because it is out of whack with the 1.
I do not understand life anymore.
All right, so if I click this, I have finished a table, it's now going to say, well, what do you think the graph would look like if you typed in an infinite number of points, typed in all those values in between the values we just did and all the values beyond them? Well, it's going to look like a straight line. And so now that we've connected the dots and it goes on and on, you see how it doesn't matter what value of X I'm trying to pick, there's a value of Y related to it. If I pick this value right here and go straight up, well, if I could go up far enough, there would be a value on the graph. So that's an example of a continuous function. All right, moving right along. These are our last 2 slides. Whoops, except I need to bring you guys with me, sorry. This one is about domain. And so it says, move the endpoints of the function to see how it changes, and watch the orange line as I move these endpoints. If I move it like this, notice my orange line just got really short, versus up there, it was a lot longer. And that orange line is just showing how far left does it go and how far right does it go. And it's covering every value of X that is graphed on this function. So if I put it up there, it's a lot longer again. So if it's covering all the values of X, that would be my domain. And so when I choose domain, it then wants me to answer the questions, why did I pick domain and what does domain mean? So I'm going to answer, I picked domain because the orange line represents, you could say how far left and right the graph goes. That would be fine. I'm going to say all the values of X on the graph. Or maybe I'll say on the function. Either one would work, but I just want to make sure I'm not saying all the X values on the grid. I'm saying all the X values on the function that has been graphed here. So domain means all the input values. Of course, that would mean the set of all X values for the function. Voila. So I'll give you guys a minute to type that. And I think some of you, as I'm looking at your answers, some of you already are fully aware. Yeah, Mr. Reed's typing it in one way, but as long as I give an answer that makes sense according to what we understand about the domain of functions, you're good. You don't have to be putting in answers identical to mine. Some of you have answered the first part, but not done the domain means part. So there are two parts. Make sure you cover both of them. Does anybody need a little more time?
I do.
All righty. Thanks for speaking up. That's that whole thing about it. Teamwork makes the dream work. We're going to make it happen. All righty. Well, I'm glad you're having some fun there, Malcolm. Just make sure it's not at the expense of all of us hardworking peoples here.
Easy. Just a little laughter to spread happiness.
Why, thank you.
This class every day.
Here, I just had this other crazy idea. You'd think, as ancient as Mr. Reed is, he would have thought of something like this long ago. Maybe I did. Who knows? But here's another way to decide it's not a function. If there's any part of the graph that if you push down on the top of the graph would then fall on another part, it's going to destroy the idea of a function. That's how we know it's not a function. If I push down on this, it's going to destroy this part of the graph because it's right above it. Versus if I push down on any of this, it's just going to go down, but it's not going to crush any of the rest of the graph. I don't know. Maybe that would be another way to think about looking at a graph and knowing if it's a function or not. All right, so let's take everybody to this very last one that we're going to do together. It's about the range. And when I drag these endpoints, you see that green region is moving up and down this time. And the up and down aspect of our graph is all about the range of our graph. So this is definitely representing the range of the function. It starts, or it only goes as high as the graph goes, and it only goes as far down as the graph goes down. So the reason I picked range is because the green line represents the, again, you could say the up and down spread of the graph. I'm going to say the y I'm going to say all of the, wow, all of the y values that are graphed. I could have said the set of all y values for the function, but that's all right. I have not yet taken time to determine which of these highly valuable young people that are currently in our Zoom class are not in this activity with us, but please, this activity is twice as much as most of our assignments. I normally make an assignment worth 10 points. This one's worth 20. So do not let your grade go down the tubes just because you didn't want to join us in this Desmos activity, guys. We're right here at the end of class, which is a little crazy. Just in case anybody wants to, I will put this right back up, but I just want to show everybody, just in case you want to keep going, and nobody has to because we'll keep working on Monday. But when you come to these videos, I think there's 3 of them maybe, make sure you maximize the video so that you can actually see what they're talking about. If you leave it that teeny tiny version, you're not going to be able to see what's going on. All right, I will see if it looks to me like all you high quality people have gotten that filled in. I'll stop this running the show so you guys can work at your own pace, but we're down to 2 minutes. So more than anything, I'll just say, have a phenomenal weekend. I try to say you do not need to work on this over the weekend unless you just are dying to. But if you have things from last Thursday and Friday, the 2 Alex assignments, one was an assignment, one was a quiz, or you haven't done yesterday's Ed puzzle yet, those would be the assignments we've had so far, aside from participation in taking our test at the beginning of the week. So make sure those other assignments are done. If you're missing any of those, take care of those over the weekend so you can be on track with a good grade. City Year will be available after school today, right, Mr. Blake, from 2:45 to 3:30.
Sure will be. We'll be there. So if you want to get some of that done, come through. We'll help you with any of your classes.
Earn your money back guaranteed.
All right. Thanks, guys. You have a wonderful weekend. We'll look forward to seeing you on Monday.
We're going 3-0 today. Yes, sir.
Going what today?
3-0.
Thrill?
3-0.
What's 3-0? Bye, Anas.
Reversing East today. Yeah, JV's going to go 3-0, and
Oh,
1.
nice. All right. I like that plan.
Yes, sir.
Is it home or away?
We're at home. Too much confidence is never enough confidence.
That's right. What? So who are you playing today?
East.
All right. All right. I taught there for 7 years. So, but have no fear, I'm on your side.
Traitor. All right, then I'll see you boys Monday.
All right. Have a great
Love
one.
it, Malcolm.
All right, thank you. If I can leave the classroom.